Maybe it's me. Maybe I'm the problem. I should consider that. Okay, so what were some of the strategies we talked about to do this, not including a calculator? What are some ways you can represent this? This will be one of these things that I'm asking you right now will be on your quiz. Okay, next on Monday. Remember, we have a quiz on Monday. So, what were some things we can do, depending on the way we see things, or what can help us count a certain way?
Number line.
Okay, we can use a number line, sure. I want to just do that one on this first one here. So these plus signs, do they matter? I mean, yes and no. Yes and no. I mean, you're shaking your head because how can you rewrite it? What can you do if they really don't matter?
Just do 8 minus 3.
Good. 8 minus 3. That's easy enough. That's going to be 5. I'm going to save a number line for the next one. Okay? Now this, you might not have thought about this a lot, but minus sent us to the left on the number line. Okay, but again, that was because we're subtracting 3. What would be another way to write this problem? How could I rewrite this problem using addition? This is a skill. The book devotes an entire lesson to it. I'm actually going to skip it because we've already talked about it, and I'm going to continue to interweave it into our other lessons. But basically, it says you can change 8 minus 3 to 8 plus negative 3. They have that as inserting parentheses to help you separate things. And I know some of you are like, wait, that looks worse. Why would you do that? Stay with me just for these next few, and you'll see why you would want to do that. Specifically, maybe letters C and D. But 8 plus negative 3, again, you think, well, which number's larger? That's going to be the sign of my answer. Right? That's called magnitude, by the way. Which number has a greater magnitude? Magnitude is another word that you might not use a lot, but when you get to physics, you will use it a whole bunch. However, last week we talked about something that was always positive that is representative of magnitude. Do you remember what it was? Had the initials AV. Did you hear that? Absolute.
Oh, absolute value.
Yeah. It was always positive because it was a measurement of. What was the definition of absolute value? Everybody remembers? Distance. It was the distance from 0. Okay, and distance is a magnitude. So which number, I could ask you, is further from 0? That would be saying which number has a greater absolute value. And it's, of course, 8 in this problem. So why is that important? Well, intuitively, you need to kind of grasp that as saying, okay, my answer is going to be the same sign as whichever number is the furthest from 0. Since 8 is further from 0, my final answer should be positive. Okay? So I get that you might not think, you don't have to do all that. No, I know you don't have to do all that. But I'm trying to train your brain to have that as kind of like a little wheel that's turning as you're doing these problems, okay? Negative 3 minus 8. So suppose I did this one on the number line. I'm sorry, positive 3 minus positive 8. I don't know why I said that. So if we start at 3 and we think, okay, well, visually, subtraction means I'm going to move to the left. I'm going to move to the left by positive 8 units. So left by 8. As Meade said, hey, that plus sign really doesn't matter. You could have written this problem as 3 minus 8. But 3 minus 8 puts us where? Negative 5. Okay. Now, what's interesting about these two problems? When we write them this way, what do you see?
One of them's a positive, the other one's a negative.
Okay, one of them's they're the same number, but one's positive, one's negative. Those are called opposites. Look at the way the subtraction, the order was written. 8 minus 3 versus 3 minus 8. See how it's the opposite order? It's the same operation, opposite order. Okay, negative 3 plus 8. Okay, so instead of, I'm going to use a number line on that one too. Actually, you know what? I'm going to do something different because nobody suggested this. I have 3 negatives and I have 8 positives. And I know you're thinking, well, isn't it kind of strange to draw pictures for math? No, not at all. not if it helps you understand the relationship. So why would I draw this picture? How is this helpful? Well, each negative takes out a positive. Once you cancel that out, what's remaining is the answer. I have 1, 2, 3, 4, 5 positives, so my answer is going to be positive 5. Is this the same? Could letter C be rewritten as one of these? Negative 3 plus 8. How could you rewrite that? What's another way to write it? Not sure. Do you remember learning about the commutative property? Commutative property said the order that you do these things in doesn't matter. But it was called the commutative property of addition. Yeah, addition. Very good. So, you see addition here. In fact, you can make all of these into addition problems as long as you keep track of the sign that's in front of them. Okay, so it is the sign that comes before the digit that tells you what kind of number it is. That is its sign, so to speak. So instead of writing negative 3 plus 8, I could turn that into 8 plus negative 3. Now, I wrote the parentheses there to help us keep track of things. But all I want you to see is 8 plus negative 3 and negative 3 plus 8 are the same problem, which you guys already told me over here. 8 plus negative 3, well, that's different than what that is, or is it? 8 plus negative 3 is the same thing as 8 minus 3, which was problem A. Okay. Letter D, these have the same sign. So, again, I'm kind of jumping around here with methods. We have a number line. We have drawing a diagram to help us keep track. This is already written with addition. Okay? That is another tactic. Like I said, there's a future lesson in your book that does that. But we're going to combine a negative 8 and a negative 3. Since they have the same sign, how do you guys approach that? Anybody want to tell me how you would approach that when they're both negative? What do you do? What'd you get for the answer? Let me start with that.
Negative 11.
Negative 11? Okay. So, how did you do that one, Cadence? What do you think that one was easy? Yeah? Why was it easy for you?
I don't know.
Well, maybe you or anybody else thought, well, I know 8 plus 3 is 11. So since I have both negatives, they're not going to oppose each other or fight like the previous 4 problems. So negative 8 and negative 3, that's just a combination of negatives, 8 and 3 and negative 11. 8 minus negative 3. Now this is the first one that's different than the previous 4. Do you remember what we talked about last week and on Monday when you have subtraction of a negative?
2 negatives become a positive.
2 negatives get together, become a positive. Okay? My philosophical analogy was when you remove a negative influence, it's a positive change. When you remove a negative influence, it's a positive change. That also will affect us in F. Negative 8 minus negative, that's the same thing. If Meta's correct, and she is, minus negative is going to turn into plus. Okay? So now that they have opposing signs, we've got to think there's going to be a battle, so to speak. We've got to figure out which number has a greater magnitude. What if I said it a different way? What if I said it more like video game terminology? When you play like Fortnite or something, when a character is stronger, what do you say? They have more strength? I don't know. Come on, I don't play Fortnite. I don't play any video games, to be honest. Huh?
HP.
HP? What is that?
I don't know what it stands for.
Oh.
No.
Health points. Oh, so they're like more alive.
Yeah.
Okay, so okay. This one's got evil health points and this one's got good health points. All right. Anyways, which one is stronger? Even though he's evil, he's stronger. But how much more is he stronger? You think about this for a second. 8 is how much further from 0 than 3? Okay, so how far is 3 from 0? Don't overthink that. How far is negative 8 from 0? What's the difference between those numbers? 5. What do I need to do to make sure I keep it correct, though? Since this number was the stronger number, my sign must follow that, okay? So that method is also explained in your book, but again, it can be unnecessary. It's really good. It's great to think that way, but I don't want you to get into the habit of having to think, okay, what's the absolute value of 8? What's the absolute value? Actually, no. When you do it that way, you have to subtract. See what I mean? I can't even write it straight, and that's on me. But the absolute value of 8 is 8. The absolute value of 3 is 3. And if you do 8 minus 3, you're going to get 5. The only thing to keep in mind is that, hey, the 8 was negative at the beginning, so that my answer would have to be negative, okay? So that's what we just did with my little health points thing. Thank you, Jeffrey and Brantley. But it doesn't have to be that complicated, okay? Do you guys feel like this is too complicated, any of these methods? We'll see on the Delta Math. We'll see. We'll see how you do. And I will welcome your feedback on, I really don't think I can get 10 right in 60 seconds. I think you can with enough practice, okay? But that's just it. It's going to take some practice. And I'm not going to give you a short little time window. I'm going to give you ample time to do that. Okay, choose 2 of the questions and explain your answers below using words or diagrams or both. I mean, we pretty much did that already. So we used the number line here for A. We used a diagram for C. Questions? On to the homework questions. Okay, so put that aside. There's notes for lesson 72 coming back for that, okay? And I just didn't want to use all my ink at home, but I would have printed that next page in color for everybody. It's just, ink costs a lot of money. Okay, so let's take a look at those homework questions. Everybody's excited about. Okay. So I had 70, 12, and 71. 15 and 22. Ooh. Okay, so 12, we're looking at the volume of a right solid. What is it? What does it say that it's a right solid? Are there wrong solids? You should talk to your doctor about that. It says it's a right solid because its base is perpendicular to the ground, or its base is parallel to the ground. Its height is perpendicular to the ground. So it's coming up like this. Okay, I definitely did that wrong, but that's all I'm getting at. That base, it's perpendicular. It's sitting straight up and down, I guess we could say, right? So, what's the volume? And its sides are 7 inches tall. It's saying it's 7 inches tall. So my little tick mark's there. And then we get this fun little shape. So it's is it a square? Yes or no? What do you think? Right angle, right angle, right angle, right angle. What kind of argument could you make that it is a square? You need to be able to make that argument. What defines a square? What are like the characteristics it has to have?
4 equal sides.
4 equal sides.
That are all perpendicular.
Yeah, very good. Very good. So he got the perpendicular part here when he said 4 equal sides, right angles. That's perpendicular. That's the definition, okay? So fantastic, Brantley. I will accept that right there. 4 equal sides. Where do you see the 4 equal sides, though? What is each side? Huh? Yeah, like what's the length of each side of the square?
10.
Yeah.
20.
20. Now the 10, what does the 10 represent, Peyton? The radius. So if you think, well, this is the diameter, It's just two of them. So 10 and 10 are really 20 on all sides. You think if the right angles are here, then that tells us that this side can jump across to this one. Same thing here. This side will jump across to that one. So this one's not really going to be easy to do a length times width times height. The other method that we learned was to find the area of the base and then multiply that times the height. Now they told us the height was 7, but we've got to find the area of this base. So the area of this base can be kind of, I don't know, do you guys look at that and then immediately like, where do I start? And the same way that you learned how to read long words a long time ago was chunk it, break it apart into pieces. Okay? So we can find the area of this entire thing by adding the areas of these three pieces. First thing I want to draw your attention to, though, is can't we do something with these two curved pieces? What would that become? If you put these two sections together. A whole what?
Circle.
Yeah, a whole circle. Do we know the area formula for a circle? Area of the circle, which equals pi r squared. And then the area of the square, what's that?
4 times side.
That's perimeter. Side times side. Side squared. So we got pi r squared. Well, r is 10. So I'm just going to write 100 pi. And then side squared, that's going to be 20. So I've got 20 squared or 400. Do you want to go ahead and just estimate? I think they said, well, they didn't say to round. But we're going to do that. So this would be 314, and this would be 400. Okay? So I've got the areas of the base, which total 714 square inches. What's left to do, I'll zoom out a little bit more, is take this part back up here and say, okay, that was the area of the base, so that's 714. Now I've just got to multiply that by 7, and we get 4,998 inches cubed. Okay. You might see that one again. I like that one. It could be fun to, when I look at that, I see a basketball court. And typically that part's painted one color, whereas the outside's something different, isn't it? Or am I imagining that? Basketball players, speak up, right? So I could ask you a question. I could say, how much paint would be required? Or how many the wheels are turning. Right? If you have so many square feet per gallon of paint, 400, and you have this section on the basketball floor that's going to be painted a certain color, I could ask you how many gallons of paint will it take? Oh, you will see that again. Okay. Or maybe we'll just make that an extra credit problem. Homework pass, anybody? I saw some eyebrows go up there. All right. The other question, 71. Come on, you guys know I just like to have fun. John just wants to have fun. Okay. 7 1/8 x plus 2 3/10. Don't you love it when they combine mixed number subtraction and algebra? That's a rhetorical question. Of course you love it. So, what do you think we should do here to get started? How did you guys do this problem? So at least one person asked about it, so I'm really not looking at them. They asked about it. I'm looking at everybody else who didn't. You want to change it? You can. We can. You don't have to do that yet, but you want to do that?
Sure.
That's cool. Okay. How do you do 7 1/8 becomes 57/8 x plus 23/10 equals 17/5. Remember, you multiply the whole number times the denominator. Algebraically, that's what needs to be your next move. You've got to do something to get x equals x equals. That's my goal. So, now what? Algebraically, again, if we're looking for the variable, we want to get rid of everything else that is preventing that. You want to remove every other distraction, you could say. So I have two distractions on the same side of the equal sign. Again, a couple people have asked, what do you mean on the same side or opposite side? This is what I mean. That is like a boundary. That's where the little teeter-totter would be if this was a balance. Right? You have like the little, actually, physical science people. What's that called? It's like the point on which they're balancing. Is that last year, physical science? Yeah. Fulcrum? Does that sound right? Hint taken. Anyways, it's balanced. So I have the two distractions. I have to get rid of them. The pattern was, we could just go with pattern, you have to get rid of the constant first. That's the plain old number. So we're going to do what to get rid of a plus 23 tenths? Yes, very good. Minus 23 tenths. And what I hope you'll remember is that, these have to have a common denominator. So why don't I go ahead and take care of that? What should be my common denominator in this subtraction problem? 10, very good. All right, so that's canceled. That's gone, you might say. And I have 57 over 8x equals. Notice, I'm keeping my equal sign. Please don't lose those. So we'll change that. You said it needs to be 10. So instead of doing this problem, I can say something over 10. What would 17 become? What did you do to 5 to get 10?
Multiplied it by 2.
Yeah. So in order for this fraction to stay equal, you have to do the same thing to the top, right, Cole? Mm-hmm. So now, instead of 17 fifths, I'm saying 34 tenths minus 23 tenths. What would that be? 11 tenths. Okay, now here comes the fun part, as if the rest of it hasn't already been fun. How do you get rid of a 57 eighths times x? I want you to see that there are two operations here. There's a multiplication by 57. There's a division by 8. You can kill both of those birds with one stone by doing we're going to multiply by the, yeah, what would be the reciprocal of 57 eighths?
8 over 57.
Yeah, 8 over 57. Do it on both sides, right, Cole? Good. So you see the 8 over 8 cancel? Now I know that I'm on the right track because x is now isolated by itself, and I just have to do this multiplication. So 88 over 570, and then maybe we can reduce a little bit, right? 11's a prime number, so I'm not really going to worry about that. But I do see that both of these could have been reduced by a factor of 2, so that's going to lead me to dividing both of these by 2 and get 44 over 285. All right, how does it? Yeah, okay. Now there's no need to change that to a decimal. That's our exact answer. As well, you can't change that to a mixed number. Okay. Last one here, 27. Less than 71. Was more of the same, right? 17 and 5/12 minus 4 and 5/6 plus 1 and 3/4. Okay, so how do you want to do this one? We don't have to change from doing proper fractions, do we? Now that would be the case if we were multiplying and or dividing. Here, we can just get a common denominator. I see the common denominator already on the page. Does anybody else see it? It's 12. Very good, Brantley. So we're going to rewrite everything that way. So 17 and 5/12 stays the same. I'm gonna switch the order of this around because, as you heard me say earlier, it is commutative as long as you consider everything can be rewritten with addition. So I'm going to have plus 1 and then minus 4, and I want to bring their fractions over. So 3/4 in terms of twelfths would be 9/12, and 5/6 in terms of twelfths would be 10/12. So let's do these separately here. 5 plus 9, 14. Take away 10. 4/12. 17 plus 1 is 18 minus 4. 14 and 4/12, or 14 and 1/3. Now, does that make sense? You could think about that like 17 minus 4 was 13 plus 1. That's 14. Yeah, that makes sense so far. And then making sure you look at these and you treat them the same way. 5/12 minus 5/6 plus 3/4. Just keeping track of the fact that that was a subtracting of the 5/6. Okay, if you guys will flip over your notes page, let's take a look at inequalities. Now don't be jealous, mine's in color. Lesson 72. Lesson 72, we're going to be looking at solving and graphing inequalities. Really just graphing them for now, okay? I don't know how much further off it is until we solve them. That could be a fun process. But graphing them. Now, you might not see something you considered a graph, but the number line will be considered a one-dimensional graph. A graph is just a visual representation of a number relationship. Now, the number relationship here is just x is 3. It's not more than 3, it's not less than 3, it's exactly 3. So, an equation that has one answer, one correct answer, that's how it would be graphed or represented visually. Right, to give you an example, you don't have to write this one down, we could say x plus 1 equals 4. That has exactly one answer. 3. Do you agree? So if I ask you to graph that answer, this is what we would produce. X is exactly 3. If it's anything other than 3, the equation is false. So that's what you've been used to. We've talked about using these to compare numbers, okay, compare values. And so now we're going to use them to compare a variable to a finite value, at least for now. So, and here's an example of that. Here's an example of that. If I try to write an inequality that represents the heights of boys and girls in middle school, and we exclude Jeffrey from the data set, then I'm going to write this. G is greater than B. So I said we exclude Jeffrey. Because in general, in middle school, girls have hit their growth spurt before the boys. So the girl's height would be greater than the boy's height. Now, I use 2 letters. We don't know what the numbers are, but I'm making a comparison, so I'm showing a relationship between 2 quantities, even if you don't know what number the quantity is. Okay? Now, we need to also make sure we know how to read these. So, greater than, doesn't matter what's in front and what's behind. When you see it in this direction, you read that as greater than. Therefore, you read this one as greater than or equal to. It's got the little or equal to line underneath it. Have you seen this symbol before? Greater than or equal to? Yeah? No? Some of you yes, some of you no. Less than. I like to think, and I stole this, I didn't make this up, that this looks like an L to help you remember. Oh, you read that as less than. It just looks like the L. Okay? So you always read that as whatever's in front is less than whatever comes after because of the direction. Okay? Do you guys know of a letter in the alphabet where the direction tells you what it's called? You can draw exactly the same thing. Turn one way, it's a B. Turn the other way, it's a D. You already do this. You just have to add this to your repertoire if you don't already have it. Okay? So that's what I put here. It's best to get used to reading the symbols based on the way that they point rather than what's there. Okay? Because like I said here, when you get to 2 variables, you don't know what G is, you don't know what B is. What this says, however, is that G is greater than B. Now, what are these going to look like on the number line? Okay, so I've given you the first one. Any number greater than 3, but not including 3. Not including 3. So what I want to emphasize here in this one that's already done for you is that is an open circle. It's empty there. 3 is not included. So, what would happen if we changed it to greater than or equal to 3? We draw our number line. We're going to put the 3. That's the only number that really matters for us, okay? We're going to go ahead and put the circle around it because that's the number that we're discussing. We're going to shade to the right I'm going to put my arrow there, make it really super obvious. But the difference here is that while this one was open because it does not include 3, this one says or equal to. So I have to color in the dot. X can be 3 or larger. What's a number that satisfies this inequality? So 3 or larger. Pick a number that is 3 or larger. 3, 4, 5, 3.07. Right, doesn't matter. 50,000. Any number that is larger than 3 or equal to 3. Another expression people might use is inclusive of 3. Okay, well, let's change it up now. Let's go the opposite direction. Let's say x is less than 3. 3 is going to be the only number I'm worried about. 3 is the boundary, or the limit, you might say. Okay, a limiting number. You can have an upper limit, or you can have a lower limit. In this one, we would call that an upper or lower limit. What do you think? Upper. Now, upper limit is like a ceiling. You can't go above it. So it's actually a lower limit. It's a lower limit because you can increase from there forever. That's what the arrow means, right? Conversely, x is less than 3. So x can be any number less than 3, such as 0, 1, 2, 2.9999995. Okay? So we're going to put our boundary at the 3, and then we're going to shade it to the left. And that's how we represent x as less than 3. X can be anything less than 3. So a number like 0, 1, negative 57, or 2.999999. I guess I could put 2.9 repeating, couldn't I? Any number that is less than 3, not including 3. Okay? Again, the visual representation for not including 3 is an open circle. Right? When you go to the 3, it's missing because it's open. It's empty. So lastly, I think you guys can figure this one out. For x to be less than or equal to 3, I'm still going to have my boundary at 3. But this time, what's different? What do you think is different? If you look at what we did up here, what's going to be different is that we'll be shaded in, and it will include all the numbers that are less than 3, such as 0, 1, 2.999, and 3. It'll include 3. So I'm going to put 3 or less. So 3 would be the upper limit in this problem. And that's how we graph an inequality. So we want to make sure we keep up with this paper as we work through the... Let me pull up the checklist for today, because I got a few minutes to take a look at... I think I wanted to talk about 73 today. Man, it's going really slow. Nope, not what I want to do. You guys realize we only have 16 school days left? Okay, so I did want to look at 73, and then if we have time, we'll do the practice sets. But 73 is cylinders. Okay. First off, what do you guys think of when I say cylinder? That's exactly what I think. Cylinders. And I would love it if we had more time to take a look at what is a cylinder actually made of. Do a little lab. But a cylinder from the side. When a cylinder is completely flat, what does it look like? I mean, surely Carson's is really close if you take off the lid. What does a can look like? What shape is a can in 2 dimensions? If you can't see it in 3 dimensions, somebody were to draw a can directly across for them, what shape would it be? Don't overthink this. You guys are way overthinking it. Yes, a rectangle made. Thank you. It's just a rectangle from the side. And then if you looked at it from the top or the bottom. Okay. So what I have given you, just right there, are the three pieces you would take if you were trying to like make a cylinder out of construction paper. And that is the lab. So that's it. It's that simple. So what are we going to do with circular cylinders? Right circular cylinders. Well, first off, let's make sure we can draw one. It doesn't have to be artistically perfect, okay, but we're just going to draw it. So if you were to kind of modify this to the point where it is in closer to 3 dimensions, we'll make our the back side of our circle there. We have dimensions, of course, related to these pieces, we could call them, that create this. So you have your distance from the center to the outside of a circle. What's that called? Radius, yes. And you have your well, we'd have diameter. We get that from radius, but the other thing that I'm wanting us to figure out here, what would you call that? Not volume. That's got to be 3 dimensions. This is just a single dimension measured from bottom to top, also known as height. Yeah. Okay. So there's 2 formulas that you're gonna work with for cylinders. The first one is we're going to look at volume. And you think, well, I have a height, but length and width are a little bit weird because it's circular. If it's circular, then we're going to use the area of the base times the height. Well, what that looks like for us is just pi r squared h. Okay? Pi r squared h. So it's just the circle's area formula and then times the height. Here's the way I like to think about that. You guys are too young to probably use CDs anymore. Most of you have probably seen them though. But if you stack a whole bunch of CDs together, what overall shape does it make?
Rectangular.
What? Makes a cylinder. It makes a cylinder. Stack all the CDs up, it makes a cylinder, right? And I like to think, well, each of those CDs has an area, and if I wanted to know how many CDs were in it, right, I could just count how many comprise the height, but I'd get a volume measurement here. That's actually something that if you go on to take calculus, you'll learn something called the disk method. Totally unrelated to CDs, but totally relevant for us. Now that's the formula. Again, that's something you should study, but you can look at how we got it. It's just a circle times the height. Okay. The other thing we're going to be finding for a cylinder, surface area. Now this is related to my 2-dimensional pictures here. Okay, my 2-dimensional pictures here. Let me get a blank one so that I don't show anybody's notes here. What could I do to start making this into a cylinder? So you do something with your hand.
Fold it into a circle.
Fold it into a circle. What do you mean? Fold is a weird word to me. You might know what you mean. When I hear fold, I think you might mean like roll it into a circle. What shape is this for now though? It's a rectangle. But if I roll it, fold it if you're Brantley, roll it into a circle. I'm going to tape it here. Now I've got first piece of my cylinder, don't I? Don't forget what this started out as. What did this start out as? A rectangle. Okay, so we'll get to the rectangle in a second. How would you tell me these 2 circles, they have an area of pi r squared, right? But how many are there? 2. What in the world am I supposed to do with this? How big is this rectangle? How do I do that? We've got to think back. How did this begin? It began as a rectangle. So it's going to be the length. So the rectangular, we're going to call that the sides of the cylinder. What is happening here? Well, this part, that was the height, right? That's the height of my cylinder, because as I roll it together, looky. I'm trying not to talk like way too much. Can't help it. Really excited. Well, the height is clearly, did that change? That's just the height of the cylinder, right? That's the height. Woo, height. I can draw on it, right? But how long is it? How long is it? What do you notice when I roll it together? This length, what does it create? What part of the circle? Yeah, it's the circumference. So the length of my rectangle, which creates the sides of the cylinder, circumference. Woo. Oh, okay, I didn't leave myself. That's the circumference. Wait, what's the circumference formula? Oh no, those things matter. You got to remember those? It's 2 pi r. Or some of you might remember it better as pi d. But look, there is my cylinder exploded, you might say. Like you take it apart. You guys like to take things apart, don't you? Was that just me when I was a baby? I tore things up and never put them back together because I didn't know. Look, there it is. There's the circumference right there. So the circumference represents the length of the rectangle, which will wrap around to make the sides of the cylinder. So if this was just length times height, or base times height, length times height, we'll just go with that. Then I'm going to insert the circumference right there, and it will be 2 pi r times h. Okay, so again, the sides, that became, or the length became the circumference. So what I've given you guys is just a way to remember. That's how that's used. It all works together to create a cylinder. Now, do you feel like I could have given you that task on your own and said, hey, figure out what the volume and the surface area formula is? I think you could have with enough time and caffeine. Okay, but look, all you're doing when you do these problems is substituting in the values that they give you. Only numbers they can give you are R and H. Okay, so if you have this, you guys should be fine with less than 73.